Hello and welcome. In this video we're going to look at what the chain rule is, when to use it, and how to differentiate using the chain rule. So first of all, what is the chain rule? The chain rule is a method of differentiating that helps make differentiating certain problems a lot quicker and easier. So when do we use the chain rule? We use the chain rule whenever we are differentiating problems where we have x raised to the power of something in brackets, but when it's not just x in those brackets, when it's x plus 2, or when it's anything that's not just x in those brackets, we can use the chain rule. Otherwise, if it's just x to the power of something, we can just move the exponent to the front and subtract 1 from the exponent. So we move our exponent to the front, so it becomes 6. X stays the same, and then we subtract 1 from that exponent, so that becomes 5. So now we know what the chain rule is and when to use it. Now let's look at how we can use it to differentiate. So let's say we have the problem y is equal to 2x plus 3 all to the power of 3. This problem is perfect for using the chain rule because we are raised to the power of 3, and in those brackets we have more than just x. So how can we use the chain rule to easily differentiate this? Well, if we were to use the power rule, first of all, it would take a very long time because first we have to expand these brackets, which is messy because it's to the power of 3, and it only gets more messy as that power goes up to say 8 or 9. And then once you have expanded it, you have to differentiate the whole thing using the power rule. However, using the chain rule, this will be a really quick and easy problem. So, to use the chain rule, you can think of it as the inside-outside rule. So, for the outside-inside rule, we have the derivative of the outside function, leaving the inside alone, times the derivative of the inside function. So that might sound a little confusing right now, but let's look at this problem, and you'll see it's actually relatively simple. We want to find the derivative of this problem here, so we have dy dx is equal to, so first we have the derivative of the outside function. What that means is what's outside these brackets. So we want to ignore everything inside the brackets. That's the next step. So what's outside the brackets? We have this 3 up the top here. So if we find the derivative of that, remember using the power rule, we take it out the front. So we get 3 out the front. And we're going to keep what's inside the brackets alone. So we keep 2x plus 3 as it is, and remember you have to take 1 from the exponent using the power rule. So 3 minus 1 is 2. So this first step we get 3 times 2x plus 3 to the power of 2. And then all that is multiplied by our second part of this equation, which is the derivative of the inside function. So now this is the derivative of what's inside the brackets. So we have 2x plus 3. 2x, that's just 2, because 2x is the same as 2x to the power of 1, and if you times that 1 by the front of the equation, we're still left with 2, and then x, 1 minus 1 is 0, anything to the power of 0 is 1, so we get 2 times 1, which is just 2. Or you could just know that's a rule whenever you're finding the derivative of something with x to the power of 1, you just drop the x and are left with whatever out the front. So in this case 2. And another rule whenever we're finding the derivative of a constant, so in this case 3, that just becomes 0. So we're just left with 2. And finally, all you have to do is simplify. So to simplify, we can simply do 3 times 2 to give us 6. And then this is already simplified as far as it can be, so that will stay the same. Meaning our derivative of this problem is 6 times 2x plus 3 to the power of 2. And we found that quick and easily using the chain rule. Now that was quite an easy example. Not all problems will be this easy, so let's look at a slightly harder example. So this problem is going to be a little bit harder than the last one. So we're still going to use the chain rule, meaning we're going to follow the same process or rule. That means we first find the derivative of the outside function, leaving the inside alone. So to find the derivative of the outside function, we get dy dx is equal to, the minus 2 comes out the front, so we have minus 2, leaving the inside alone, so the inside will stay exactly how it is. And we subtract 1 from the power. So minus 2 minus 1, remember this is minus, so minus 2 minus 1 is going to be minus 3. Careful not to make that minus 1. So we get minus 2 times 4x to the power of 3 minus 5x, all to the power of minus 3. And now we're going to multiply that by the derivative of the inside function, so this part here. To do that, we move the 3 out the front, so we get 3 times 4, which is 12, x, and we have 3 minus 1, which is 2. And for our second part of that problem, remember we just drop the x because x is to the power of 1, meaning we just have minus 5. And we'll put that in brackets. Now, this problem isn't quite as neat as the last problem, and most problems won't be neat. So that means we'll have to simplify this to make it as neat and simplified as possible. To do that, let's just have dy dx is equal to, now because this is to the power of minus 3, if we move that down the bottom, we can have that to the power of positive 3. So let's move that down the bottom and we get 4x to the power of 3 minus 5x, all to the power of 3. And on the top we have minus 2 times, and that's times this bracket over here, which is 12x squared minus 5. Now that was a bit easier than having to multiply these two together, which is why we did it, and this problem has now been simplified. So that example was a little bit harder, but still pretty easy. So if you would like me to do another video on this, just comment below and maybe I'll do some harder chain rule problems so you can get used to that. But I hope you found this video on what the chain rule is, when to use it, and how to use it helpful, and if you did, please consider liking and subscribing. See you next time.